Okay, so there's question 10a. Now there's actually a word missing from the question, so this word here I've underlined should be in the question as well. So what it should say is, does the point 3,5 lie on the graph of y equals x plus 2? Now y equals x plus 2, that's in the form y equals mx plus c, where m is the gradient, which would be 1 in this case. So that's a straight line, which looks a bit like that. And what it's asking us is, this point 3,5, does it lie on the line? So does it lie on this line anywhere? Is that point 3,5 there? Or is it here? Is it here? Is it here? What we want to know is, does it lie on the line? Right, so it's quite straightforward what we do here. All we do is we look at the point that we've been given. We know that's an x coordinate and a y coordinate. And we substitute that into this equation. And if it satisfies the equation, what I mean by that is, if it makes sense, then that point lies on the line. If it doesn't satisfy the equation, then it does not lie on the line. So let's substitute in and see. Y equals x plus 2. Y for us is 5. X for us is 3. Does that make sense? Does 5 equal 3 plus 2? Yes, it does. So that tells us, therefore, 3,5 does lie on the graph. Had we got something which did not make sense here, that would tell us that the point does not lie on the graph. So let's look at another example. So I'm looking now at the example, I think it's the last one in question 10. So does the point 3,7 lie on the graph of y equals 3x plus 1? Same idea. Let's sub in our values of x and y. So y equals 3x minus 1. Y in this case is 7. So that equals 3x. X for us is 3 minus 1. 3 times 3 is 9. Minus 1 is 8. So 7 does not equal 8, of course. So that tells us that the point 3,7 in this case does not lie on the graph. Okay, so to conclude, if the point satisfies the equation of the line, it does lie on the graph. If it does not satisfy the equation of the line, then it does not lie on the graph.